In 5 years, your observability stack won't need you to debug it. It'll debug itself and fix the problem before you even wake up.
Wait, are you saying AI agents will actually run production systems autonomously? So we're covering automated root cause analysis, how knowledge graphs work, and whether SREs can actually trust these systems.
By minute 7, you'll know exactly when to start preparing for this shift. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into the rise of agentic AI in production. Can observability systems run themselves?
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's been keeping platform engineers up at night. Not just managing observability systems, but the possibility that those systems might start managing themselves. We're seeing AI agents that can supposedly detect, diagnose, and even fix production issues without human intervention.
Wait, are we talking about basic anomaly detection here or something more sophisticated?
Way beyond that. I'm talking about AI agents that can navigate your entire production environment, understand dependencies, trace through distributed systems, and make decisions about what's actually broken. Spiros Xanthos from Resolve AI calls it building agents that work alongside humans. But the real question is how long that alongside part lasts.
That's a massive leap from the alerting rules we're used to. How does an AI agent even begin to understand a production system that most humans struggle to fully grasp?
That's exactly the right question. Traditional observability gives us metrics, logs, traces, tons of data. But there's this gap between having the data and knowing what to do with it. Manoj Acharya from Grafana Labs talks about knowledge graphs and context graphs, essentially teaching AI systems to understand not just that something is broken, but why it's broken based on the relationships between services.
But production systems are messy. Documentation's outdated, services have weird dependencies nobody remembers.
And that's where this gets interesting. These new systems are trying to build what they call context graphs in real time. They're not relying on your outdated wiki pages. They're learning by watching actual traffic patterns, API calls, database queries. The AI builds its own map of your system.
So instead of me spending 3 hours at 2 a.m. tracing through logs to find that one misconfigured service 3 hops away from the user-facing error,
the agent could theoretically trace that path in seconds. But here's what's really wild. Some teams are already letting these agents take action. Not just, hey, I think the database is the problem, but I've rolled back the last deployment because it introduced a memory leak.
that's both amazing and terrifying.
Right? And that tension is exactly what we need to unpack. Because the technology is here, but the trust isn't. Coming up, we'll dig into exactly how these systems actually work under the hood, what they can realistically do today versus the hype, and why your SREs might be more skeptical than you'd expect.
And I really want to understand the technical architecture. How do you even build an agent that can reason about distributed systems?
Oh, we're definitely getting into that. Plus the economics, because if agents are making API calls and running queries 24/7, somebody's paying for that compute.
The on-call engineer in me is intrigued, but also deeply suspicious.
As you should be. Let's dive deeper. All right, so let's break down how these agentic observability systems actually work. The architecture is fascinating. You've got 3 main components working together.
Walk me through it.
First, you have the context graph Manoj mentioned. This isn't your traditional service mesh diagram. The AI is building a living model by analyzing actual traffic patterns, API calls, database queries, even deployment histories. It's learning that when service A talks to B and B queries database C, a spike in C's latency probably affects users hitting A.
But how accurate can that be? My systems have so many edge cases.
That's the clever part. They're not trying for perfection. Spiros made this point that really stuck with me. It doesn't have to be perfect. The agent builds confidence scores. Maybe it's 85% sure the database is the issue based on patterns, but it knows to check the app server logs too. It's probabilistic reasoning, not deterministic rules.
So what does an actual investigation look like?
Picture this real scenario. Users report slow checkout times. Traditional approach? Page the on-call engineer, they check dashboards, dig through logs, correlate timestamps, maybe wake up the database team. With an agentic system, the AI immediately sees the pattern, checkout API latency spike correlating with database connection pool exhaustion. But here's where it gets interesting. It doesn't stop there.
It traces deeper?
Exactly. The agent queries the deployment system. Was there a recent change? Checks the database metrics. Query patterns different? Examines the app logs. New query without proper indexing? And it's doing this across your entire stack in parallel. One agent reported finding a new unindexed query introduced in a feature flag rollout that only affected 15% of users. Try finding that manually at 3 a.m.
Okay, but how does it actually interface with all these different systems? My logs are in Datadog, metrics in Prometheus, traces in Jaeger.
Tool calling and API integrations. These agents use function calling capabilities. Essentially, the AI can execute predefined queries and API calls. Show me P99 latency for service X. Get recent deployments for service Y. Check database slow query log. Each observability tool becomes a function the agent can invoke. The magic is in knowing which functions to call and in what order.
That sounds like it could get expensive fast. All those API calls, the compute for the AI reasoning.
You're hitting on something crucial. Cyril Tovena from Grafana brought this up. In an agent-first world, who pays for what? If the AI is constantly querying your metrics to stay aware of system state, that's thousands of API calls. If it's analyzing every log line with an LLM, your costs could explode. Some teams report 10x increase in observability costs during pilots.
So what's the ROI calculation there?
Compare it to engineer time. Senior SRE salary plus the opportunity cost of them debugging instead of building. One company calculated that if the agent prevents just 2 Severity 1 incidents per month, it pays for itself. But that assumes the agent actually prevents incidents.
Which brings us to trust. How do SREs actually react to these systems?
Mixed, honestly. I talked to a staff engineer who said, I trust it for investigation, not remediation. They'll let the agent do the detective work, find the slow query, identify the misconfigured service, but when it comes to roll back this deployment or restart this service, they want a human in the loop. There's this uncanny valley where the AI is almost too good at mimicking how a human would investigate, so you forget it doesn't actually understand your business logic.
That's terrifying. The agent doesn't know that restarting the payment service during Black Friday is different from restarting it on a Tuesday night.
Exactly. And this is where we hit the real limitations. These systems are pattern matchers with access to tools. They can trace symptoms to likely causes based on past incidents. They can even predict impact. But understanding business context, making judgment calls about acceptable risk, knowing when that weird error is actually expected behavior for that one legacy integration, that's still deeply human.
So we're not replacing SREs? We're giving them superpowers?
For now, but the trajectory is clear. Today's AI helps investigate becomes tomorrow's AI fixes with approval, becomes next year's AI handles routine incidents autonomously. The question is where your organization draws the line. Stick around. We'll talk about exactly how to evaluate these systems and what questions to ask vendors who are pitching you autonomous production management.
Okay, so let's get practical. If I'm evaluating agentic observability for my platform, what am I actually looking for?
Start with your incident data. Pull your last 50 production incidents, categorize them. How many were obvious cause, known fix? How many were complex investigation, unique solution? If 70% of your incidents are database connection exhaustion or pod memory limits, AI agents can handle those today. If you're debugging race conditions in distributed transactions, maybe not.
What about integration complexity?
Critical factor. These agents need API access to everything. Your metrics, logs, deployment systems, potentially your infrastructure. One team spent 3 months just getting authentication sorted across all their tools. Ask vendors, what tools do you support natively? What's the integration effort? Can I limit what actions the agent can take? You want granular controls. Investigate anything, but only restart services in staging.
How do we even measure success?
3 key metrics: mean time to detection, how fast does the AI spot issues versus your current alerts; investigation accuracy, when the AI says database is the root cause, how often is it right; and critically, false positive rate on automated actions. One false rollback during peak traffic could destroy trust forever. Start with shadow mode, let the AI investigate and recommend, then compare against what your engineers actually did.
What about the human side? My SREs are skeptical.
As they should be. Don't position this as replacing expertise. Position it as eliminating toil. Your senior engineers shouldn't be checking disk space at 2 a.m. They should be designing systems that don't need checking. I've seen success when teams let engineers help train the AI. Here's how I'd investigate this type of issue. They become architects of the automation rather than victims of it.
Vendor landscape. Who's actually shipping this today?
Resolve AI is the pure-play startup bet. Grafana's building assistant capabilities into their platform. Datadog and New Relic have AI features, but less autonomous. Honeycomb's taking a different approach. AI helps query, but humans decide. Key differentiator? Are they selling you better dashboards or actual autonomous agents? Ask for live demos on your system, not canned ones.
Red flags to watch for.
Our AI handles any incident type? Run away. No human oversight needed? Huge red flag. Reduces headcount by X%. They're selling to finance, not engineering. Look for vendors talking about specific use cases, integration challenges, and human-in-the-loop controls. And demand to talk to current customers, not just read case studies.
Timeline for adoption?
If you're starting today, months 1 to 2 is integration and baselining. Months 3 to 6 is shadow mode and trust building. Months 6 to 9, limited automated actions in staging. Month 12, maybe production remediation for well-understood scenarios. This isn't flip-a-switch technology. The organizations succeeding are treating it like platform engineering, iterative, measured, with engineering involvement throughout.
What's the 5-year view here?
Here's my take. We're heading toward AI systems that don't just respond to incidents, but prevent them. Imagine agents that watch your staging deployments and say, this query pattern will cause production issues under Black Friday load. Or agents negotiating between services. Database agent tells application agent to rate limit because maintenance is starting. The philosophical question? When AI can run production better than humans, what do SREs become?
System designers rather than operators?
Exactly. The engineers who survived the shift from manual server management to Kubernetes, they became platform architects. Same transition coming. The value moves up the stack from I can debug production to I can design systems that rarely need debugging. Your job security isn't in gatekeeping production access. It's in understanding distributed systems deeply enough to teach AI how to manage them.
That's actually exciting rather than threatening.
Right? But only if we approach it thoughtfully. Don't chase autonomous operations because it sounds cool. Start with specific pain points. Measure relentlessly. Keep humans in the loop until trust is earned. And remember, even the best AI can't replace understanding why your systems exist and what your users actually need. That context, that judgment, that's still uniquely human. For now. Before we wrap up, let's catch up on this week's infrastructure news.
There's a fascinating development in cloud security. Datadog just announced expanded protection for Oracle Cloud Infrastructure resources. They're bringing their cloud security platform to OCI with some pretty comprehensive coverage.
OCI has been growing steadily. What kind of security features are we talking about here?
According to their announcement, they're offering vulnerability scanning, compliance monitoring, and threat detection specifically tailored for OCI workloads. The integration hooks directly into OCI's native services.
Makes sense. As more enterprises adopt multi-cloud strategies, having consistent security tooling across AWS, Azure, and OCI becomes critical.
Speaking of cloud infrastructure vulnerabilities, here's a sobering reminder. AWS experienced outages in their UAE data centers due to drone attacks, as reported by the BBC.
Wow, that's a stark example of how geopolitical conflicts can impact our digital infrastructure. What was the extent of the damage?
The strikes in UAE and Bahrain caused service disruptions, highlighting how physical security of data centers remains crucial. It really drives home the importance of geographic redundancy in your disaster recovery planning.
And this is why platform engineers need to think beyond just technical failures when designing resilient systems.
On a more positive note, Confluent just dropped a major platform update with some game-changing features for Kafka users. The new stack reports they've added A2A protocol support, multivariate anomaly detection, and, get this, queues for Kafka.
Queues for Kafka? That sounds like they're bridging the gap between traditional message queuing and streaming.
Exactly. It's about democratizing real-time data processing. The anomaly detection feature is particularly interesting for platform teams managing complex event streams. Here's something for the JavaScript ecosystem. npm-x just announced their alpha release. It's a new, fast browser specifically designed for navigating the NPM registry.
Do we really need another NPM tool? What's wrong with the existing registry interface?
According to their blog post, npm-x emphasizes speed and modern UI. For developers who spend significant time searching through packages, this could actually improve productivity.
I'll be interested to see if it gains traction. The NPM ecosystem definitely could use some UX improvements.
Now, this is cutting edge. Cloudflare's blog reveals they're working with Google to test Merkle tree certificates as a replacement for traditional TLS signatures.
That's a fundamental change to how we handle certificate validation. What's the motivation?
It's all about efficiency and scalability. As the number of certificates explodes, Merkle trees could provide a more scalable approach to certificate transparency and validation. Finally, OpenTelemetry Collector version 0.147.0 just dropped with some notable improvements. The highlight is enhanced exponential histogram support in the debug exporter. It now outputs bucket counts at normal veracity.
That's going to make debugging histogram data much easier. What else is in this release?
They've also added metadata-based partitioning for the sending queue batch configuration. You can now partition batches based on client metadata values, which is huge for multi-tenant platforms needing better control over data routing.
That metadata partitioning feature could really help with performance optimization in large-scale deployments.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.